Today we will be discussing section 4.1 from your textbook, which is a section on matrices. And what we see right here is an example of a matrix. A matrix contains items of data, and as you can see, matrix A here contains 6 items of data. And the first topic I'd like to discuss when we look at matrices are the dimensions of a matrix. Now matrix A has dimensions 2 by 3, indicating that it has 2 rows and 3 columns. So the dimensions of a matrix are given by number of rows by number of columns. In a matrix such as matrix A here, the items of data are called entries in the matrix. And to make it easier to refer to a specific data item or a specific entry in a matrix, we use matrix addresses to help us communicate which piece of data we're talking about. So, for example, if we wanted to refer to the 0, that piece of data in matrix A, we would say that this is entry A32, where the lowercase a here shows us that the entry is in matrix uppercase A. The 3 shows us that we are in the 3rd row, and the 2 shows us that we are in the 2nd column. So it's the row number and the column number that determine the address. So just for one more example, if I wanted to refer to entry A21, well, the little a tells me I'm looking at matrix big A, which right now is the only one on the screen. The 2 here tells me that I'm looking at the 2nd row, and the 1 tells me that I'm looking at the 1st column, so A21 is 7. And just as a little bit of review, let's remember that the dimensions of A are 3 by 2. We've got 3 rows and 2 columns. Now we'll like to perform several operations with matrices, and the first and one of the simplest operations is adding matrices. So we'll look at 2 matrices A and B, and it is very important when we look at adding that these 2 matrices have the same dimension. Now to add these matrices, we would just say A plus B. Well, we're just going to add the entries that are in the same spot in each matrix. So I'll add A11 to B11. I'll get 1 plus negative 5 here, and I will add A21 to B21, and I will get 4 plus 3, and the result of my addition in multicolor will be negative 4, 7. And I subtract matrices in more or less the same way. I would say A minus B. Well, I'd say that's 1 minus negative 5, and 4 minus 3. So I'm just subtracting the entries in the corresponding positions, and I would get 6, 1. So I'll modify this note up here to just remind us that we can only add or subtract matrices when they have exactly the same dimensions. And we'll take a look at another example of adding matrices where the matrices are a little bit larger, but it's exactly the same process. So adding these 2 matrices here, I will get that A plus B is equal to 2 plus negative 2 is 0, 0 plus negative 1 is negative 1, negative 2 plus 1 is negative 1, 4 plus 12 is 16, negative 3 plus 0 is negative 3, and 0 plus 3 is 3. The final operation that we're going to discuss today is scalar multiplication. Scalar multiplication is what we do when we want to multiply a matrix by a number. So given this 2 by 2 matrix A, we could ask, for example, what is 3A? And we would calculate 3A by multiplying each of the entries in matrix A by 3. So we would have 3 times 7, 3 times 2, 3 times 5, and 3 times negative 2. would give me a resultant matrix of 21, 6, 15, negative 6. So remember, we've done scalar multiplication where we multiplied a matrix by a number. A little bit later we will actually look at multiplying two matrices together, but today we're just multiplying a matrix by a number. Now finally, I can actually combine operations like addition, subtraction, and scalar multiplication. So given these two 2 by 2 matrices, A and B, I could ask, for example, what is A minus 4B? And the way I would start this out is to say, well, first of all, let's leave A alone and find out what 4B is. So I have 2, 1, 0, 2. And then I'll subtract from that 4B, which is going to be 20, 12, negative 12. And 4 times 4 is 16. And then I can perform the subtraction. 2 minus 20 is negative 18. 1 minus 12 is negative 11. 0 minus negative 12 is 12. And 2 minus 16 is negative 14. Again, all of the matrices in this subtraction problem had dimensions 2 by 2, and the dimension of my resultant matrix is likewise 2 by 2. And we'll take another quick look at entries and addresses. So I've got matrix M here, it's a capital M, and let's say I ask about the entry M34. That's going to be the third row and the fourth column of this matrix, so that's going to be equal to 1/2. But be careful here, because say for example I asked about entry M43. Well, that's telling us to look at the fourth row. Well, there's where the fourth row would be. There is no fourth row. So I might ask you a question like this where there is no answer because there are simply no entries of the matrix at that location. Now finally, I might ask you a question like, what is the address of 4 in matrix M? And in order to answer that, we would look and we would say, okay, that's going to be the third row and the second column. So we would have that M32 is what's equal to 4. That's all the instruction that we have on this section, and please take a look at the problems that I'm going to ask you to prepare for class. So for class tomorrow, please, for problem 1, perform scalar multiplication to find negative 2b. For problem 2, calculate what 1/2 a plus b is equal to. For problem 3, identify the entry at address A21. Number 4, identify the entry at address B32. And in number 5, please write the address of the 0 in matrix A. Thanks, and I will see you tomorrow.